Incredibles. All right. So, second part is 6-3. First of all, let me make sure we're clear on this. Let me make sure we're all clear on this. Let me make sure we're all... okay, I got you now. What does a logarithm do? Cancels a base. Logarithms come in different bases because you have to cancel all sorts of different bases, right? There are two logarithms in particular who are so special they've been given their own name. One of them is called the Common Logarithm.
Doesn't sound all that special.
It is special.
Sounds pretty common.
It is uncommonly common.
That's what we can start.
Hey, check your calculator out on the left side, fourth button up. Left side of your calculator, fourth button up. Do you see a log button?
Yeah.
Hit the log button.
Log button has been hit.
Does it allow you to type in any kind of base?
No.
It does not.
You already told us.
Did we talk about this last time? This sounds familiar. Anywho,
Had to have a special calculator because
this is what it is. You guys write this down. A common logarithm is a log base 10. And since it's used so frequently, and I guess scientists are kind of lazy, they don't write the 10 anymore, they just write log. If you see log with no base, it really does have a base. It's base 10. Okay? So that logarithm I had you put on your calculator, what kind of logarithm is that? Common logarithm. It's base 10. Okay? You with me? The reason it's called the common logarithm is you use it a lot. You use this logarithm a lot. For two reasons. One reason is there's a button on your calculator. Okay? Second reason, who's in chemistry? Raise your hand. Chemistry people. Chemistry. Only 4 or 5. What?
I like to think that.
What about physics? Or who's had chemistry before? A couple of you? Does scientific notation ring a bell? Scientific notation ring a bell?
Well, in scientific notation, isn't it something like 3.14 times 10 to the negative 2? Is that scientific notation? Anything in scientific notation always has a power of 10 in there somewhere, right? Did your chemistry teacher talk to you about this? Why is it a power of 10?
He just said because I told you so.
Because it moves the decimal, right? If you move one spot in a decimal, you moved it by a power of 10. That's why they're called decimals. Because guess what deci means? 10. 10. Deci means 10. So decimals are powers of 10. If you move the decimal spot twice, that's a power of 10 squared. Anywho.
Are you sure it's not pronounced deca?
Decimal. But anyway, if you're dealing so often in scientific notation with bases of 10, wouldn't it make sense that you would deal with logarithms of base 10 quite often? That's why it's called the common logarithm. You use it with a lot with scientific notation. Anywho, here's a problem I want you to practice. Rewrite, if you can. That's a challenge. It's a dare. I dare you. I triple dog dare you to rewrite log of 1,000 is equal to 3. I want you to rewrite that in exponential form.
If you think you can handle it. Think into exponential form, yeah. So without giving too much of it away, your task really is to cancel the logarithm. Because in exponential form, there is no logarithm.
Just put another logarithm. I think it would just be 3 equals 2.
Not quite.
I think if you push it to the calculator, the log of 1,000 is just 3.
Yeah.
Could you just write 3 equals 3?
Think about what you guys did on the quiz. Consider, hold on. Consider how you guys did number 5. Look at number 5 on the board. How did you cancel that log base 3? Did you do a base of 3 on both sides? How did you do question 6? Didn't you do a base of 9 on both sides?
So you do base of 10.
Well, what cancels a logarithm if there's no base? But there really is a base, but it's not there. Doesn't this really have a 10 right here? So what would cancel a log base 10?
Log base 10.
Not a log base 10. Just a base of 10. So put a base of 10 on both sides. Okay. Down, I need you to write for me. You've got nice handwriting. No, but I need you to write for me, so you don't read your book. Go up there. Come on now. You can do it.
Well, we can have race names.
Take the pen of power. Put a base of 10 on both sides. Now you guys are he's the scribe, you're the mouthpiece. You tell Dallin here what to cross out. So the log and the 10 cancel out. So what's the answer? 1,000 equals 10 to the third. Thank you. Okay, the thing to take away from this, you guys. Number one, if you see a logarithm with no base, what kind of logarithm is it? Come on, I need you with me. It's a common logarithm. It's log base 10. Here's the second thing you need to take away from this. What cancels a common logarithm? A base of 10. Okay. Here's the next special logarithm. And if you ask me, this one's even more special. It's called the natural logarithm. It's all natural. There's no preservatives. Natural logarithm.
Why would you take out the R? You just said logarithm.
Logarithm?
No, you're actually not right.
There's an R right there.
Okay, A. Would you say logarithm? There's no logarithm.
Oh, logarithm? Logarithm? Yeah. True. True. Okay. I'm going to see if you guys can guess this. It's just an ordinary logarithm with a very peculiar base. This logarithm gets its name from the base of the logarithm. Think back to section 6.2. I introduced you to a brand new number, a number you had never seen before. And it was called the natural number. E was called the natural number, right? So here's my question. What's the base, do you think, of the natural logarithm? It's E. All the natural logarithm is a log base E, like this. Well, I will show you. That's a great question, Down, and I will show you in just a second. Here's the thing, though. You will never, ever see it written as log base E, except for right now. You're looking at it. But other than right now, this second, you'll never see it written as log base E. They write it as LN. Look at that! Isn't there an LN button? Third button up on the left side. Log natural is LN. Creativity. Seriously though, look in your calculator. Do you see the LN button? What does LN stand for? Natural logarithm. They got it backwards though, didn't they?
They did. It's okay that we can't explain it to the guys.
Why is it backwards? Does that bother anybody? It was really bothering somebody in my last class. The L and the N. Shouldn't it be NL for natural logarithm?
Unless you got it backwards and you're just teaching us wrong.
Well, isn't it LN on your calculator? So TI-84 got it wrong too? Unlikely. No, it is LN. Reason is logarithm is a Latin term. You guys don't speak Latin, but some of you in here I bet are taking Spanish. Who's taking Spanish?
Oh, it's against my religion.
And
It's more like a
do you speak Spanish, Dave?
I understand
A little bit. So in Spanish, the noun comes first, and then the adjective comes second, right? Natural is an adjective. Logarithm is a noun. So since this is a Latin, and Spanish is a Latin-based language, they would say this as logarithmus naturalis. That's why it's backwards. Anywho, here's what you take away from this. What is the natural log? What is the natural log? Come on. It's ln, but is it any different than any other logarithm? It's just a log with a base of e. A lot of students see this ln and think it's this brand new type of logarithm that's so fancy. It's just a log with a base of e. You with me? It's no different than a log base 10 or a log base 2. It just cancels a very particular base. What does a log base e cancel? A base of e. That's all. Just like any other logarithm cancels a base. So here's your task. Oh, mama. Let me rewrite that. I want you to rewrite
This equation into logarithmic form. E to the third power is equal to x. Ready? Go!
e to the third power is equal to x. Now we can work on this one together here if we need to. But I just said it like 5 seconds ago. What cancels a base of e? ln. So if I put an ln right next to a base of e, guess what happens? They cancel each other out. But this is an equation, so you have to do the same thing to the other side. So you do ln on the other side. So I'm going to see if I can write with my mouse. 3, so far so good, equals, that is a 3. You just went on Weight Watchers. ln of x. There we go, got it. 3 equals natural log of x. Okay. So I'm going to give you 4. I want you to write question 1, 2, 3, 4 just in a line on your paper. I'm going to give you 4 practice problems here. They're just like these. I'm mixing in some of the old logarithms that you did last time with some of the new and improved logarithms. So, practice. Rewrite. Oh, crap. I got to erase.
It connected something to pants. Like,
There you go.
clenching your butt.
What?
Yeah, that actually happened in class. Yeah, he's like, clench your butt. He's like, see, now you're all rising. Yeah.
What? So, if you're not too busy clenching your butt, get going on these 4 problems.
Excuse me. I'll probably see when it comes out. I'm not going to pay $9 to see it in theaters.
That's why you just watch.
Let's see. Need a new scribe. A new scribe.
Be careful, don't read your books.
Don't make eye contact.
No, you make eye contact. If you don't get called up.
You're challenging. You so.
How often do I get called up? I mean, like, you only call me when I'm actually reading my book. Otherwise, I'm staring into your soul.
Are you looking at my soul? Oh, let's see. Lexi, you want to be our scribe?
See, she wasn't making.
Did you see that look? It was no, I don't, but I'll do it anyway. I know what that look was.
Okay, but she's only the scribe. You gotta tell her what to write. Thank you.
All right. We'll start with Mason. He looks like he's ready to go. On question 1, Mason, tell her what to write.
So much for
You ready?
Yeah.
You need to phone a friend.
Mason.
Other Mason.
I don't know.
Well, what did you do? How do you get rid of a logarithm? We might need some help here. Who can help us out? Don't bring the log over. We're trying to get rid of the logarithm. What cancels a logarithm? A base. A base of 4 on both sides. There you go. Now we got to cross something out. Come on, you guys. You got to pick this up. Tell me what to cross out. Log base 4 and the 4. So your final answer is? 64 equals 4 to the 3rd. Nice. All right, we'll have Lexi do one more, and then we'll choose a new scribe. Let's do question 2. Ooh, this was a tough one. This was a tough one. What do we think? What do we think? What do we think? What cancels a logarithm?
Another logarithm.
A logarithm doesn't cancel a logarithm. A base cancels a logarithm. So you have to match bases, though. What's the base of that ln? E. So what base do we use on both sides? Base of E on both sides. There you go. Now what should she cross off? ln and the E. So the final answer is 4 equals E to the X. Fantastic. Thank you. All right, I've been picking on people in the front. We got to pick on people in the back. Josh! Okay. He sprung right up. He was hoping to get called on. Okay. My last class struggled on question 3. They really struggled on question 3. I'm going to take control of your pen here for a second. We need to cancel this 10. Would you guys agree? What cancels bases? Logarithm. What particular logarithm are we going to use to cancel that? Just the log, common log. Go ahead and write that. Log on both sides. There you go. Just kind of squeeze it in over there somewhere. Yeah, that'll do. What is Josh supposed to cross out now? The 10 and the log. So our answer is -2 equals log 1 over 100. Sweet! Okay, we have one more. Oh, I think we can do it. One more. We what? Log base 4 on both sides? Well, wait a minute. We got to come to a consensus here.
Yeah, there's nothing else that can be.
There's nothing else that could be?
Yeah, I'm pretty sure it's a log base.
Log base 4?
Yeah.
You guys just going with the crowd?
Wait, no, that wouldn't work because then it'd be 4 square roots of 16. But that doesn't equal 2.
It is log base 4 on both sides. What cancels a base of 4, you guys? A log base 4. Go ahead and write. Log base 4. And then on the other side, log base 4. There we go. What should Josh cross out? 4 in the log base 4. So 2 equals log base 4 of 16. Nice. Thank you. Okay. Yes.
So is that on the last one, you did the 16, should it be an exponent 16 or just like a regular 16?
It'd be a regular 16 inside the logarithm. So this is what we actually started last time. I jumped the gun, so let's just kind of restart as if we hadn't done it yet. So this is a new topic. Even though it's not, it's a new topic. Evaluate a logarithm. Sometimes it can be done just in the old head. It doesn't have to be done on a calculator. For example, let's see how smart you guys are. If I asked you to evaluate the square root of 81, you would all say 9. If I asked you for the square root of 144, you would say 12. But if I asked you for the square root of 7, crickets chirping. Right, so sometimes square roots could be done with a calculator, sometimes without. You agree? It's the same thing with logarithms. Sometimes you can evaluate with a calculator, sometimes you cannot. So these ones are going to be no calculator. Turn them off, take the batteries out, throw them away. Well, you'll need them in a second, so maybe hold off on that.
You laugh ticket?
Mushu. Mulan. So, write this down. Log base 8 of 64. This is an example of a logarithm that can be evaluated without the use of a calculator. It is no lie.
Could you use a calculator?
I don't know. I really don't know. So,
Could we all agree that this equals something? Could we agree that it equals something? Okay? If you're unsure of what it equals in logarithmic form, guess what you can do? You can rewrite it in exponential form. Those two things right there that I have written mean the exact same thing. They're just in different forms. One's logarithmic, one's exponential, but they mean the exact same thing. So looking at it this way, is the answer more clear? It has to be 2. The answer has to be 2. Log base 8 of 64 equals 2. That's one way that you can evaluate a logarithm. Okay? And comparing it to like square roots. You guys are great at square roots because you have a lot of practice. It's not that they're easier than logarithms, you just have more practice with them. Evaluating a logarithm can be just as easy as evaluating a square root with practice. So, oh shoot. Pretend you didn't see that. Log base 2 of 8. Log base 2 of 8. We can try the same thing. We can say, well, I don't know what that equals. So I'm going to put a question mark there. And then, if you don't like logarithmic form, you can change it to exponential form, and boom! The answer becomes quite clear. I hope. What is it? 3. The answer is 3. Not so bad. I wouldn't doubt that some of you get to the point where you can start popping these off in your head. Should we test that? Let's try it.
No.
Log base 3 of 9. 2. Log base 10 of 100. 2. I gotta be more creative. Log base 4 of 64. Oh, crap! Alright, so some of you guys can do this in your head. That's great. If not, put an exponential form. Now, there are some that require no thought at all. These might have required your brain to flicker for just a second. But some of these don't require much brain activity to answer. Here's one of those. It doesn't seem like it at first, but once I tell you what the answer is, you're going to be like, what? That's so dumb. Why is math so easy?
Natural log of e to the 4th power. Now, if you think you know it, don't yell it out. Keep it in, hold it deep down inside. Bottle it down in there somewhere. Let's give us a chance to stew about this. It's not. What am I trying to say? The answer's there. The answer's there. You just have to unlock it.
Isn't it the problem of all math problems?
Yeah, but this one's more simple. It's more simple than it appears. Let me ask you a couple of leading questions here. What does a logarithm do? Well, first of all, isn't this a logarithm? What does a logarithm do? It cancels a base. What base does a natural logarithm have? So what base does a natural logarithm cancel? Do you see what the answer is then?
4.
The answer is just 4. The natural log and the e cancel each other out. What a dumb question, huh?
Okay, let's put one of those on our test.
The answer is just 4. Oh. Which test is it you need? Alright, back to this.
We want to decide.
Seriously, Do you understand why the answer is 4?
Because the ln crosses off with the e.
It disappears, so you just are left with a 4. Okay, well, along those same lines,
Check out this bad boy. Before you start hyperventilating, it's a 7. Before you start hyperventilating,
I do have a question though. Like, does this like help make anything like the iPad or anything? Like,
logarithms?
yeah.
Yeah, they're used a lot.
For what though?
Lesson 6.6 is titled Applications of Logarithms. So if you can wait till then, you'll see some.
So actually, for some reason, like we're just learning crap.
Yeah, we're just learning useless crap that nobody ever uses.
That's what they teach us in history.
History is supposed to teach you a lesson so you don't repeat the mistakes of the past.
And how sniper script they have and like different things about cameras.
anyway, what's the answer here? 7? 7?
7.
You guys seem pretty confident. It is
one we've just started.
It is 7. The answer is 7. Why? What cancels a logarithm? The base. Since they have the same base, those will cancel each other out, and the answer is just 7. All right.
You know, thanks to people like that, whenever you write an answer, just accidentally.
Sometimes it requires the use of the calculator, though. Like this one, log base 3 of 11. What the? Log base 3 of 11? Is 11 a power of 3? No. Absolutely not. Even if you try to rewrite it into 3 to some power is equal to 11, that makes it even less clear. So you
change the base form.
You pick up the calculator. Well, first you write this down. The change of base formula.
Hey! You what now? Okay, guys. Shh. Check it out. This is something you will have to have memorized for the exam coming up in a couple weeks. Here's the dilemma. Most calculators, not all, I'll show you what I mean in a second, but most calculators cannot do logarithms that have bases other than base 10 or base e. Aren't those the two logarithms I've shown you on your calculator, the LOG and the LA? Most calculators can only do those two bases. Okay? So there's something called the change of base formula. This logarithm has a base of b. That's no good. Calculators don't really know what to do with that. So you rearrange the problem into this. I need you guys to look up at the screen for a second. You see where my arrow's pointing? What's the base of this logarithm right here? Base b. That's a problem. But what's the base of this logarithm? 10. What's the base of this logarithm? Why is that so much better? You have that on your calculator. And if you don't like the LOG, you can always use this form of it. What's so nice about the natural log? That's also on the calculator. So we've gone from a logarithm that you cannot do on a calculator to logarithms that you can do on a calculator. So this problem here, log base 3 of 11. If you apply the change of base formula,
It'd be the log of 11 divided by the log of 3.
it'd be the log of 11 divided by the log of 3. And that you can type into your calculator.
So you type in log of 11, close parenthesis, divided by log 3, close parenthesis, enter. Well, would you look at that, 2.18. And if for some reason you just don't like that LOG button, you can also use the natural log button if you're one of those naturalists. Natural log of 11 divided by the natural log of 3. What do we expect to get as an answer here? 2.18. What? Weird. Okay. That's called the change of base formula. Now, if you're fortunate enough to have the TI-84 Plus Silver Edition, you might be able to do logarithms with different bases without having to use a change of base formula. Check it out. Hit the math button. Scroll up. Do you see where it says log base? Hit enter on log base. What the? Look at that. You can type in a little teeny 3 down there. And then you can scroll over and type in an 11 and hit enter. And my word, 2.18. Boom. Now, I don't need you to complain about it because it is what it is. The decision has been made by all of the secondary 3 teachers. Are you listening carefully? The decision has been made by all of the secondary 3 math teachers that regardless of what calculator you have, on the test, a question like this, you need to show all of the steps on how a normal quote-unquote calculator would have to do this. So you would have to write this as log 20 divided by log 4, and then you would write your answer. If you just go straight from here to an answer, even if it's right, guess what? It's not right. You follow? You need to show your knowledge of the change of base formula. What is that, by the way? Log 20 divided by log 4. 2.16? So here's what I want you to practice with. Try that one right there. Log base 3 of 17. Log base 3 of 17. On your mark, get set, go. And again, remember, just having the correct answer is not good enough. You've got to show your vast knowledge of the change of base formula. You just describe, they'll tell you what to write. There you go. Pretty sweet, huh? Okay. He's an instrument in your hands. He writes what you say as it relates to math. Okay, listen. He knows. You guys have chosen one speaker for the entire class, huh? All right, log 17 divided by log 3. And the answer is? What did you say? 2.58. What do we get over here? 2.58. I think it's a keeper. 2.58. Thank you. Well, that's logarithms. Don't you love them? Don't you love logarithms? Who loves? I love logarithms. Love's a strong word. I hold them in high esteem. They're easy to use. They are fun.